And third method which comes under closed hashing or open addressing method is double hashing. Double hashing is an advanced collision resolution technique which is used in open addressing for hash tables, and it involves using a second hash function to compute the prop sequence. So, here if you check the formula of double hashing, there are two hash functions we have used, and the second hash function is used to complete the prop sequence h2 of k into I is nothing but the prop value which is used to compute the prop sequence. So, here in double hashing method we will be using the second hash function to compute the prop sequence, which helps distribute the keys more uniformly and reduces clustering. So, here with the help of this double hashing method, somehow we will be able to reduce the clustering. So, and totally there are two hash functions we used to determine the prop sequence. When a collision occurs, it applies the second hash function to calculate an offset, which means the prop value, which is then used to find the next slot to prop. So, until we find an empty slot, we are supposed to increase the prop value and perform. And this is the formula. H of k comma I, k is a key value, I is a prop value, h1 of k is the first hash function, h2 of k is second hash function, mod m is the table size. And also you have to ensure that the hash function should be used in such a way that the hash address, the hash value generated by the two hash functions are distinct. Since we are using two hash functions, you must ensure that the hash values generated from these two values must be distinct. It should not be the same, which means you have to use two different hash functions, or you can use two same hash function with different prime values. Some differences must be there. We cannot use the same hash function with the same set of values. If so, we would end up with getting same hash values only. So, you have to ensure that two different hash functions are generating two distinct values, not the same value. So, first we will compute the index, compute the initial index, initial address using the first hash function. If it fails, like if the collision occurs, then we use the second hash function here. If the slot is occupied, compute the step size using a second hash function, which is h2 of k. So, if one fails, we are performing the another one to identify the alternate empty slot without creating any clustering. Let us discuss the example. We are supposed to insert the key values 26, 13, 25, 31, 39 and 52 using the hash table size of 13. Yes, we have created the hash table with the size of 13, and we know the formula for double hashing method. This is the formula of double hashing method. Two different hash function, and second hash function is used to compute the prop sequence mod m, and two different hash functions. Both the functions are using modulo division method only, but for first hash function I used the value 13, and for second hash function I used the p value of 12. So, you all know the formula for modulo division method. H of k equals to k mod some p value. Here for first function I use the p value of 13, and for the second function I use the p value of 12, and the table size is 13 and initial prop value 0. Let us apply this formula to generate the hash value for the given key values. First key value given here is 26. So, apply the formula. K value, h of k value is 26 and initial prop value 0. Apply the formula. First hash function has h1 of k, which is k mod 13, 26 mod 13 plus 26 mod 12 into 0, which means the entire term would become 0, right, h2 of k into 0. Since the I value is 0, the entire term would become 0 mod m. If you compute, you would be getting the value 0. In this place you will get 0, 23 mod 13. So, 0 mod, this is not m, this is 13, m value is 13, right. 0 mod 13 is again 0 only, which means in the place of 0, 0 is empty only. In the place of 0, you can place the key value 26. The second key value is 13. First key value 26 we successfully inserted into the hash table, and the second key element which we want to insert into the hash table is 13, and initial prop sequence is 0. So, apply the first hash function 13 mod 13 plus, since initial prop value I is 0, this entire second hash function would become 0 mod 13. 13 mod 13 again it is 0, 0 mod 13 there will be 0 again. There is a hashing, sorry, there is a collision here because already at index position 0 we placed some other key value 26, right. So, in the same place we cannot place another key element which is 13 over there. So, increase the prob value, that is 1, and now if you check here you get 0, 13 mod 13 is 0, 0 plus, and second hash function is k mod 12, k is 13, 13 mod 12 mod, sorry, 13 mod 12 into 1 mod 13. Now 13 mod 12 we all know it is 1, 1 star 1 1, 1 mod 13 is going to be 1. Check the slot 1, 1 is free only. So, in the place of 1 you can place the value 13, and the next key value is 25, 25 comma initial prob value 0, apply the formula 25 mod 13, and since prob value 0 h2 function would become completely 0, and then mod 13. 25 mod 13 is 12, 12 mod 13 is 12 mod 12 mod 13 is 12 only, because 25 mod 13 is 12, 12 plus 0 is 12, 12 mod 13 is 12 again. Check 12, 12 is free only, so in the place of 12 we can insert a new value 25. And next key element which we want to insert is 31, and initial prob sequence is 0, apply the formula 31 mod 13 plus second hash function will become 0 since I equals to 0 mod 13. 31 mod 13 is 7, 7 plus 0 is 7 again. So, 7 mod 30, the hash value is going to be 7. Check the 7th slot, yes, index position 7 is free, you can insert 31 over there. And next key element I want to insert is 39, apply the formula h of 39 comma 0 equals to 39 mod 13, and second hash function will become completely 0 since initial prob value 0. And now if you apply the formula 39 mod 13, it is again 0 only, 0 plus 0 0, 0 mod 13 it is 0 again. So, if you check the hash value 0, hash at the 0 is already occupied. So, collision here, since it creates a collision, try identifying the next slot by incrementing the prob value from 0 to 1, apply the formula 39 mod 13, this would become 0, 39 mod 13, and apply the second hash function here, key value is 39, 39 mod second hash function is k mod 12, right, 39 mod 12 star I value is 1, right, 1 mod 13, 39 mod 12 is 3, 3 into 1 is 3, so 3 mod 13, the hash value would be 3. Check the index position 3, yes it is free, in the place of 3 you can insert 39 now. And the next key element which we want to insert is 52, apply the formula for 52, initial prob value is 0, if you apply the formula you would get 0, because 52 mod 13 is going to be 0, hash function is hash function 2 is completely 0, mod 31. So, since this is 0, 0 plus 0 again 0, 0 mod 30, we have collision here. So, increment a prob value 52 comma the prob value is going to be 1 now. So, 52 mod 13 is 0 plus 52, second hash function formula is k mod 12 star 1 mod 13. 52 mod 12 is 4, 4 into 1 is 4. So, 4 mod 13 is going to be 4. The hash value which has been generated for the key element 52 is 4. 4 is free only, in the place of 4 52 can be inserted. So, this is how the hash value, the alternate location will be computed with the help of the double hashing. method. So, in the double hashing method we use two hash function 1 and hash function 2. Only with the help of hash function 2 only the probing sequence can be computed, because it is the probing value has been multiplied with the hash function 2 only. And finally, after identifying hash function 1 and hash function 2, we need to sum it up and perform again the mod function with the table size. And after computing the hash value, like whenever we face a collision, I think you would have understood how the second hash function works here. Hope it is clear. Now, let us discuss the advantages, disadvantages and applications of using double hashing method. When it comes to an advantage, the very first one is reduction of clustering, because here double hashing minimizes both primary and secondary clustering here. With the linear hashing method we face the problem of primary clustering, and with linear probing method we faced the primary clustering problem, and with quadratic probing we faced the problem of secondary clustering. So, here with the help of double clustering we can minimize somehow the primary clustering and secondary clustering, leading to more uniform distribution of keys and shorter probe sequences. So, if you check here, not more than 2 probe sequences it is taking, and also like if you check the linear probing and quadratic probing, it took more number of probing sequences, but if you check, it has taken only minimal number of probing sequences wherever the collision has been occurred. Why? Because we are using two different hash functions here, and also probing sequence also we have included here. So, two hash function and also probing sequences helping us out here to generate the hash value with the minimum probing sequences itself. And the second one is efficient space utilization. It makes this double hashing method makes efficient use of the hash table space by providing at variable intervals, reducing the likelihood of long runs of occupied slots. And third one is good performance. Double hashing provides better average case performance for insertions, deletions and searches compared to linear and quadratic probing, especially as the load factor increases. So, when the load factor increases, load factor in the sense what I mean here is table overflow and other stuff, multiple probing sequences, but here with the double hashing method we are going to face only less probing sequences. So, compared to linear and quadratic probing, we have minimal load, like we will have minimal load factor, and also if the load factor increases also we will be getting minimal probing sequences here. So, good performance can be expected here with the help of double hashing. And fourth advantage is predictable probe sequence. The probe sequence is deterministic and depends on the key, which makes it easier to trace and debug compared to other complex collision resolution technique. And next are disadvantages. First disadvantage is complexity, because here implementing double hashing is more complex than linear or quadratic probing, because it requires designing two hash functions that are relatively prime to the table size. And the second disadvantage is performance degradation with poor hash functions. If the second hash function is not well chosen, it can lead to poor distribution and poor performance degradation. So, ensuring the functions are effective here and efficient requires which requires careful design. So, ensuring the functions are effective and efficient, which requires the careful design of the hash function. And third one is increased computation overhead. The need to compute two hash functions for each insertion and search operation increases the computational overhead compared to simpler methods like linear probing or quadratic probing method. And next are applications. First one is hash tables in programming languages. Double hashing is used in implementation of hash tables in many programming languages and libraries, particularly where performance and space efficiency are critical. So, all these applications are common, many applications are common with a linear probing as well as with quadratic probing method. Second application is caching systems. In caching systems where collision resolution efficiency is crucial, double hashing helps to maintain fast lookup times, fast retrieval times and efficient space utilization. Third one is database indexing. These three applications we discussed under linear probing as well as quadratic probing method. Hashed indexes in databases sometimes use double hashing to handle collisions, ensuring uniform key distribution and efficient access times. And the next application is network routing tables. This double hashing method can be used in network routing tables where quick lookups and efficient memory usage are necessary. And Next application is security applications. In security applications where the hash based structures are required, this double hashing method can be used, which provides a balance between performance and collision resistance, which makes it a preferred choice. In summary, this double hashing is a collision resolution technique in hash table and uses only second hash function to compute the probe sequence, which would reduce clustering and it would improve the performance as well. With the help of double hashing performance, it is possible, and it offers efficient space utilization, good average case performance and predictable probe sequences, which makes it suitable for various applications including programming languages, CAD systems, database indexing, compilers, network routing tables and security applications.